We're getting there, everybody. This is 8.8, applying properties of parallelograms 2. So in this lesson, we're mostly going to be working with the diagonals. So this is the one where we need to remember that given a parallelogram, the diagonals bisect one another. So if we have a diagonal there and a diagonal there, they cut each other in half. So the parts of the red diagonal are congruent and the parts of the blue diagonal are congruent. So that's the big one for this lesson. So we'll dive right into it. This one says solve for x. They gave us a diagram. Again, it doesn't show us that it's a parallelogram, so I'm going to add some parallel markings to it so that it is. Make sure that you are adding the names of the vertices, so F, G, H, and E to each of those corners. And then we're going to use this information to see what we can find. So they tell us that ZH is 16. So if we go here and we find ZH, we know that that is 16. Okay. So what I would do right away is I would just, right after you do that, go find the rest of that diagonal, and it has to be the same. So if Z to H is 16, then Z to F also has to be 16. So I'd fill that in right away. I don't know if that's going to be useful or not, but let's have it just in case. And then the other bit of information they give us is that FH is 15x plus 2. So now they're giving us FH. So from here to here is 15x plus 2. Okay, well, do we have enough information to solve this problem? Absolutely. So we're given FH in two different ways. FH is 16 plus 16, which is 32. So FH, I'm just going to write it right over here, 16 plus 16 is 32. So we're given FH in two different ways. We're given a number and we're also given an expression with variables in it. So let's just set those two equal to each other. 15x plus 2 is the same as 32. And we end up with x equals 2. Now we could totally try it. We could plug that 2 back in. So we could do 15 times 2 plus 2. 15 times 2 is 30. 30 plus 2 is 32. So yeah, that whole distance is 32. If you split it in half, you get 16 on each side. So I'm happy with how that one turned out. All right, and then last example here, example 2, we're going to solve for both x and y in this situation, and I think it's maybe a little bit tricky to read there. These diagrams sometimes get a little clunky. But we can use that whole diagonal thing again. So we know that the diagonals bisect one another. So that chunk and that chunk are congruent, and that chunk and that chunk are congruent. So I'm just going to start with the x's and say 3x equals 12. It's that simple. Divide by 3, and x has to be 4. And then the other one is just going to be more work. But this left diagonal and this right diagonal, or half a diagonal, are going to be equal to each other. They have to be. So 3y plus 1 equals 2y plus 5. Let's solve it. Let's get all of our y's to the left. And we end up with y equals 4. Again, let's check it quick, maybe just in our head. So if we substitute 4 in for y, we got 3 times 4 is 12, and 12 plus 1 is 13. And then over here, we have 2 times 4 is 8, and 8 plus 5 is 13. So that looks awesome. You guys can go ahead and work on the practice for 8.8.